Okay, so let's start summarizing organic chemistry. Now, organic chemistry might look like a very big chunk of the syllabus. Indeed, it does take up a lot of marks. But what you need to know is that organic chemistry is the study of carbon-containing compounds. Okay? So everything we are studying here must be carbon-containing compounds. And carbon is a fantastic element because carbon, you know, has an electronic configuration of 2,4. This means that carbon has 4 valence electrons, which is to be expected because carbon is from group 14 of the periodic table. Now, because carbon has 4 valence electrons, it requires 4 more valence electrons to achieve a fully filled outermost shell. So 4 valence electrons means it needs 4 more electrons to achieve a fully filled outermost shell. And hence, carbon will always share 4 electrons, and hence it forms 4 bonds. Now, this is crucial to get because whenever you are drawing the structures of organic compounds, you need to ensure there are 4 bonds around every single carbon atom. There must be 4 bonds only, not more, not less. Okay, so this is the common careless mistake that many people make, which is there are more than 4 or less than 4 bonds around the carbon. So do take note about that. Now, in this particular chapter, we're going to be studying and summarizing the main concepts in organic chem. Of course, it's not everything, but this should help you get through most of it. Now, the first thing to take note of is organic compounds come from living things. Okay? So all of us contain organic compounds. The word organic comes from the word living. But in particular, in industry, we are going to be extracting them from crude oil. Crude oil is also known as petroleum. So petroleum is a mixture of organic compounds. Specifically, petroleum is a mixture of hydrocarbons. And we need to know crude oil or petroleum, because it's a mixture, to become useful, you need to separate it. And so we separate crude oil using fractional distillation. And the reason why we use fractional distillation is because the compounds have different boiling points. Okay? And that settles how we actually separate crude oil into its respective components. Okay? Now, we're going to move on straight into the homologous series themselves. Okay? So, organic compounds are really, really diverse. There are many different types of organic compounds. Hence, it is important to categorize them into families. Now, these families of organic compounds, they are called homologous series. So, we are going to look at alkanes, then alkenes. And for the express students, we'll be looking at alcohols and carboxylic acids as well. Okay, so now without further ado, let's go into the first homologous series. Now, it's always very helpful to summarize alkanes and alkenes side by side. So may I encourage all of us who are watching this video, the good way to study really is to ensure that you summarize alkanes and alkenes side by side on a piece of paper. So you could actually divide your piece of paper into 2 different columns so that you can see the differences next to each other. Now, the first thing you need to know is that if they are in the same homologous series, for example, if they are all alkanes, they have the same general formula. So alkanes have a general formula of CnH2n plus 2, where n is the number of carbon. Now, n always represents how many carbon atoms you have in the particular organic molecule. Okay, so alkanes, so long as they are alkanes, they belong to the alkane homologous series, the general formula will be CnH2n plus 2. Okay, now n is just the number of carbon. N can be 1, 2, 3, 4, 5, 6, or even 100, 1000. Okay, so let's just practice a little bit. If n is equals to 8, you sub in n equals to 8, you get C8H 2 times 8 plus 2, which gives you C8H18. All right. So this formula shows you that it's an alkane because it follows the general formula CnH2n plus 2. Right? It follows this thing. Okay, so it's quite common. They do ask you, explain how the formula C8 H18 show that it's an alkane. It's an alkane because it follows the general formula CnH2n plus 2. Okay, so all alkanes have the same general formula. Now we move on to alkenes. All alkenes, so long as they are the same homologous series, same general formula. So alkene, all of them, CnH2n. Again, n is the number of carbon. Okay, so you notice now, okay, alkenes is CnH2n. Don't have the plus 2. Okay, so we're going to practice again. What if n is equals to 8? 8 carbon atoms. C8H 2 times 8, which is C8H16. So you can see the molecular formula C8H16 tells you that it follows the general formula CnH2n, and therefore this is an alkene. So very commonly in MCQs, they will also ask you, which of the following is an alkene? Alkene is CnH2n, meaning the hydrogen is double, is twice that of the carbon. So if you notice, if it's CnH2n, C8H16 is an alkene. All right. Other examples could include C2H4, C3H6, C4H8. If the hydrogen is double that of the carbon, then that's an alkene. Okay. Now, so that's it for general formula. The next thing we should look at is something called functional group. So if you recall, functional group means the specific atom or group of atoms that gives rise to the unique characteristics, chemical reactions of that homologous series. Are there any special atoms or groups of atoms which give rise to specific chemical reactions? So for alkane, alkane has no functional group, meaning alkanes do not have any special atoms that are unique, that give rise to very special chemical reactions. However, alkenes have a functional group, and that's the carbon-carbon double bond. Okay? Now, because alkenes have the carbon-carbon double bond present, we say that alkenes are unsaturated. Now, the word unsaturated in organic chemistry means the molecule contains at least one carbon-carbon double bond. Okay? So in the case of alkenes, they have one carbon-carbon double bond. Therefore, we say that alkenes are unsaturated molecules. We are going to come back to this in a short while. How do you actually test for unsaturation? Okay? Now, so alkenes are unsaturated because they contain carbon-carbon double bond. Alkanes, we just said, they don't have a functional group. Alkanes do not have a carbon-carbon double bond. So what that means is that in an alkane, all the bonds are single bonds, single lines between all the atoms. And because of this, we say that alkanes are saturated. So you need to be familiar with these words, saturated versus unsaturated. Now, if I zoom out, just ensure that you have taken these main points down. If you need to pause the video recording at this point, please pause it so that you can take down everything that you have just learned. Okay? Now, the word saturated, unsaturated refers to the presence or absence of a carbon-carbon double bond. Now, moving on. We will now study the reactions of alkanes and alkenes. Okay, we're going to summarize the reactions. Again, it's not very difficult. Most students find it very difficult to memorize. Having said that, if you take notes in the right way, it should be quite straightforward. Now, alkanes undergo two types of reactions. There are two names, two types of different reactions. The first type of reaction is combustion. And this is where you need to be very careful. Combustion, there are two types. There is the complete combustion and there's the incomplete combustion. All right. Now, the complete combustion produces CO2 and H2O only. All right. So complete combustion only produces carbon dioxide and water. incomplete combustion occurs when you have limited oxygen. So whenever you have a limited supply of air or limited supply of oxygen, that's when incomplete combustion happens. Now, when incomplete combustion happens, it produces a mixture of CO, which is carbon monoxide, soot, and water. Okay, so that's the first reaction of alkanes. Now, in particular, for complete combustion, you must be able to balance the equations. Okay, so how do you go about doing that? So let's just revise once more. So let's say you had this particular alkane. Now, this is C3H8. C3 means it's prop. Remember, the first part of the name tells you how many carbon. The prefix prop tells you it's 3 carbons. The formula C3H8 tells you it's an alkane because it's CnH2n plus 2. So this is propane. So if it's propane, how does it undergo combustion? To balance the equation, first things first, combustion needs oxygen. Oxygen is O2, not O. Okay, oxygen gas is O2. It's diatomic. Now it produces CO2 and H2O. It is important to leave some space because now you have to balance the equation by writing coefficients in front of the chemical. So leave some space in front of each chemical. So once you have done this, you have written the formula out correctly, the next step is to balance. You always need to have a system. The idea in balancing is to balance out the number of atoms. Always have a system. Start balancing the carbon first. There are 3 carbons in this alkane, C3. Therefore, we balance the carbon with CO2 by adding the same number in front of CO2. So it has 3 carbon dioxide molecules formed. After you are done with that, the next step is to look at the hydrogen and balance the hydrogens. You have 8 hydrogens on the left. You must also have 8 on the right. You now have 2 on the right. How do you convert 2 and multiply it with something to form 8? 2 times what equals 8? So the answer is 4. You are adding a coefficient in front, so it's multiplication. 4 H2O. If you have 4 H2O, you will have 8 hydrogens because 4 times 2 equals 8. Now, the last step really is to ensure you count the oxygens carefully. 3 CO2. 3 times 2 equals 6 oxygen. 4 H2O. 4 times 1, 4 oxygen. 6 plus 4 oxygen is 10 oxygen. And because of this, now on the right-hand side, what number do you need to fill in before the O2? How do you make 10 times oxygen from O2? The answer is 5. If I have 5 O2, 5 times 2 equals 10 oxygen. Okay? And that is how you balance an equation for complete combustion. The steps are you balance the carbon with CO2. So if I were to highlight, I balance my carbon with CO2 by adding the same number in front of CO2. The next step, I balance my hydrogens with my H2O. Taking into account there's 8 hydrogens on the left, I will need 4 H2O. The last step is to add up the oxygen on the right, and now I will insert a number before O2 on the left to ensure I have the same number of oxygen. So it's C, then H, and lastly O. Have this system every single time you're asked to balance an equation for combustion. Okay? Now, the second reaction of alkanes is called substitution. Now, this again is not difficult to understand. It's very easy to grasp. Okay? It's the idea of replacement. I'm replacing one of the hydrogen atoms with a halogen like chlorine. So over here, I replace one of the H with a Cl. And this produces HCl in the process. Okay? Now, it need not stop at just replacing one hydrogen. it could replace all 4 hydrogens in this molecule. Okay, so substitution does not mean that I just stop at 1 hydrogen being replaced. I could replace it, all of them, with chlorines. However, for the purposes of writing an equation to show substitution, for simplicity, to make it simple, we're just going to show 1 being replaced. Okay, now what is important in organic chemistry is to learn the names of the reactions as well as the conditions for each reaction. So what is the condition? The condition for substitution is ultraviolet light. So it's very important to learn the reaction together with its condition. Okay, and usually we will write the conditions into the equation below the arrow as well. Okay, so UV light or ultraviolet light is needed for substitution. And that really concludes the 2 reactions of alkanes. Now, we can go to the reactions of alkenes on the right-hand side. Now, again, there are just 2 types of reactions. The first reaction should be familiar. It's combustion. Again, combustion, there are 2 types. Complete, incomplete, depending on the amount of oxygen available. If there is a lot of oxygen, it's complete combustion. If there's limited supply of oxygen, then it's incomplete combustion. Of course, we are always focusing on complete combustion when writing the equations. So again, we can practice a little bit. So now I will give you a different alkene. Okay, so now we have C2H4. C2, let's revise. C2 means 2 carbon. 2 carbon means the name has to start with F, ETH. F means 2 carbons. So just now we had prop. Prop is 3 carbons, F, 2 carbons. Now ethene is an alkene, so it's ethene or ethene as we commonly say. So ethene is C2H4 plus O2 forms CO2 plus H2O. So again, make sure you write the formula correctly first. Now, you may wish to pause the video at this point so that you can practice how would you balance this particular equation for complete combustion. Okay, what did we say just now using the alkane as an example? Now let's apply it to alkene. Which element will you count first? Which element will you balance first? So if you have tried, I hope you have had the time to try a little bit. The idea is always balance the carbon first. So it's C2, so 2 CO2. It's after the carbon is done, the next one is hydrogen. It's H4 on the left. Therefore, I also need 4 hydrogens on the right. So be very careful. There's already 2 hydrogens on the right. So it's 2 H2O, not 4 H2O, because 2 H2O means 2 times 2. You have 4 hydrogens already. Finally, the last step is to count the oxygens. If you have counted the oxygens carefully, 2 CO2 has 4 oxygens. 2 H2O has 2 oxygens. 4 plus 2 oxygens is 6 oxygens. Therefore, the number to put in front of O2 is 3. So it's C2H4 plus 3O2 forms 2 CO2 plus 2 H2O. And that's the balanced equation for the complete combustion of ethene. Okay, so we finished combustion of alkenes. The next thing we need to know is what is the second type of reaction for alkene. The second type of reaction is addition. And this is where it gets interesting because addition literally is what you learn in primary school. 2 plus 3 equals to 5. 4 plus 2 equals to 6. So the idea of addition is to put 2 things together to become 1. 2 plus 3 equals to 5. 2 numerals added together became 1 larger numeral. So same here. 2 molecules added together became 1 larger molecule. So example, okay, 2A, C2H4 plus H2. 2 different molecules, C2H4 plus hydrogen. Add them together, just simply add. So it's C2, how many hydrogens? H6. Okay, so the idea is I added the two molecules together to form a single larger molecule. C2H6 is larger than C2H4 or H2. Okay, now this is addition of hydrogen. Addition of hydrogen is called hydrogenation. Okay, so this is very important to realize. Adding hydrogen, addition of hydrogen, hydrogenation. Now, hydrogenation requires 200 degrees Celsius of temperature. And the catalyst is nickel. So we use nickel metal to speed up this reaction. Okay, and hydrogenation is used in making margarine from vegetable oil. So the margarine that's spread onto the bread is made from vegetable oil, but vegetable oil is a liquid. So to solidify the vegetable oil, we actually perform hydrogenation, which is addition of hydrogen across the double bond. Okay. Now the next type of addition, we need not add H2, we could add Br2, bromine. Again, just add them together to form one product. So the idea is one product on the right. So it's C2H4 Br2. That's it. Okay. C2H4 Br2. Okay. Now, just now hydrogenation is adding hydrogen. Now we add bromine. There must be a name too. Now this is called bromination. I brominate the alkene, meaning I'm adding bromine across the carbon-carbon double bond in the alkene. Okay? So bromination does not require a catalyst. Bromination does not require heating. Bromination takes place simply at room temperature. All you need is aqueous bromine. And this is particularly important, so I would like for all of us to highlight this, aqueous bromine. Now, how is this important? Remember just now we mentioned alkenes have a functional group called carbon-carbon double bond, right? Alkenes have a carbon-carbon double bond. Therefore, alkenes are known as unsaturated. So now let's link the aqueous bromine to unsaturated. You may wish to use your pen or your highlighter to draw a link this way. Okay, now it's very important when you're writing notes to link this way so that when you study, it's a visual reminder for you. Okay, aqueous bromine is a test to show that something is unsaturated, to show that something has a carbon-carbon double bond. So aqueous bromine is important for showing that something is unsaturated. Why? And this is where we write down. If there is carbon-carbon double bond present, it's unsaturated. The aqueous bromine is decolorized. It's decolorized from reddish brown to colorless. Okay, just let me spell it correctly. It's COLOURLESS, so colorless. So it's very important to learn the color change. Aqueous bromine is decolorized from reddish brown to colorless if it's unsaturated and it has a carbon-carbon double bond present. All right. So that's the second type of addition reaction. It's still addition, but now you're adding bromine. So we have seen adding hydrogen, we have seen adding bromine. The one with bromine is particularly useful because there is a color change from reddish brown to colorless. So it's very, very easy to tell, hey, if the aqueous bromine is decolorized, then there is a carbon-carbon double bond present. Now, the last type of reaction, which a lot of students have forgotten, is actually called addition polymerisation. It's also addition. All right. And this one, I believe many students have forgotten. And therefore, we are now going to summarize these two before we end the first video, which is on alkanes and alkenes. All right. Now, addition polymerization, again, is addition. Nothing difficult about it. But what's difficult about it is that very often we love to give you an alkene whereby it's not as simple as C2H4. Now, C2H4 is really straightforward. This is C2H4, right? C2H4, 2 carbons, there is a carbon-carbon double bond. What if I had many molecules of C2H4? I have n molecules of C2H4, where n is just any large number, any big number, large number. Let's say I have 1 million C2H4. What's gonna happen? Well, we can imagine addition might happen. How does it happen? They just join together like Lego bricks. The double bond is the glue that allows them to join together because the double bond can break. The double bond breaks left and right. Double bond, left, right. So it becomes an ongoing chain with many, many, many ethene molecules joined together. The 4 different atoms attached to the double bond did not change. What just changed is double bond broke left, open, right, open. Then you just bracket it up and put N. What this means is a single large polymer has been formed. Now this, of course, is called polyethene. It's polyethene because it was formed from the polymerisation of ethene. Polyethene. The word poly actually means many. So in this case, many ethenes joined together. That's called polyethene. Now, polyethene is useful because it's a waterproof material. Polyethene is used for making plastic bags so that it's waterproof. It doesn't allow water to seep through, especially if you are carrying something wet like vegetables, fish that you bought in the market. Polyethene can also be used to make raincoats. Again, why raincoats? It's because polyethene is waterproof. Okay, so polyethene is very, very useful. Now, polyethene is still relatively straightforward. But what if we moved from polyethene to a different alkene to start with? What if we had C3H6 propene? Right? So what does propene look like? Propene has 3 carbons. It's an alkene with 3 carbons. The question is, does it have 2 double bonds? Or does it just have 1 double bond? There are 3 carbons. Clearly, you must have bonds between them. Are they all double bonds? Or is it just 1 double bond? And the answer is just 1. The other bond is single. Okay? So even though there are 3 carbon atoms in propene, only 1 of the bonds is a double bond. The others are single bonds. And that's true for bigger alkenes. No matter how big the alkene is, so long as it's an alkene, there is only 1 carbon-carbon double bond. Okay? Now, the next step, of course, is to remember right at the start of this lesson, we said carbon only forms 4 bonds. Therefore, need to ensure I count. The carbon on the left still has 3 bonds to hydrogen. That means 3 hydrogen atoms. The carbon in the middle has 1 bond drawn on the left, 2 bonds drawn on the right. Therefore, 1 bond, 2 bonds, 3 bonds. 3 bonds have been drawn already, and therefore there is only just 1 hydrogen attached to the middle carbon. Finally, the last one on the right has 2 hydrogens. You notice that this molecule is drawn like this, and it's absolutely correct. It's absolutely correct because every carbon has 4 bonds around itself. Okay? So the idea is not to fill up blank space. No, please don't fill up this blank space with bonds. There are no bonds there. There are no atoms there. All right? The idea is every carbon just has 4 bonds. The blank space doesn't bother me because I have ensured every carbon has formed 4 bonds. Clear? Now, this molecule is commonly tested. Of course, this is a 3-carbon alkene, so it's propene. Propene is very commonly tested, so you need to know this. Okay, and many students make the mistake because they wanted to fill up something in the blank space below. Please don't do that. All right, just ensure every carbon has 4 bonds around itself. Okay, so propene again can polymerize. All right. So if I have n numbers of propene molecules, they can join together by addition polymerization. But how would you draw it? How would you draw the polymer? And that's the key that most students get lost with. Now, the idea is not to start immediately with this particular structure. You need to redraw the alkene first. And how will we do that? What I will do is I will take a highlighter and I will always highlight the functional group, the carbon-carbon double bond. Now, after I've done that, I will copy out the carbon-carbon double bond again below. Okay? Then I will analyze the two carbons in the double bond. What is attached to each carbon? So the carbon on the right should be quite straightforward. There's two hydrogens, right? This one easy. There are two H's. And now you notice I've drawn one below, one above. Okay? How about the carbon on the left? The carbon on the left has one hydrogen attached to it, but there's another very long-looking group. If I may highlight the long-looking group. There's a C, there's a H, there's a H. So we're going to summarize this as CH3. All right. Now, what do you notice? I've basically redrawn my propene molecule in this H, letter H shape. Always do this letter H shape. How do you do this letter H? Just highlight the carbon-carbon double bond and figure out what is attached to each carbon. Okay? So on the right-hand side, there's two hydrogens. On the left-hand side, carbon, there's one hydrogen and one CH3 group. Now, once you have done this, drawing the polymer is easier. Because what did we say about polymerization? It's the carbon-carbon double bond, opening left, opening right. So you just open left, open right. The rest, copy and paste. And that actually is the essence of our addition polymerization. Now, the brackets, you will notice I've used curved brackets, but in reality, you will see both curved and square brackets, okay? I would think square brackets a little bit neater because the structure is quite big. So using square brackets perhaps is easier, all right? Now, this is the structure of the polymer called polypropene. And why I call it polypropene is because it's made from propene. Okay, so propene, remember, you have to redraw the molecule into the letter H shape. This is a key step that must be done. If you do not do this redrawing step, then you are going to face difficulties with drawing the final polymer. Now, the next thing before we end this video, the polymer must always have just two carbon atoms in the middle. You can have more carbon atoms above and below it, but you cannot have more than two carbons in the middle. So the middle section, which is the middle part, the skeletal part of this repeating unit, this middle part should only have two carbons. Okay, so this is the structure of polypropene. Now, what if you were asked to draw the repeat unit of polypropene? The repeat unit basically is the structure minus away the brackets. So the repeat unit is just this. Don't want the square bracket, just whatever is inside the bracket is the repeat unit. Okay, so you need to get used to drawing the structure as well as the repeat unit itself. All right, now polymers are really useful. Just now I said polyethylene is used to make plastic bags, raincoats, polypropene as well. Now, polypropene can be used for a variety of uses. Polypropene actually can be used to make certain plastic ornaments, cutleries. Okay, now again, because it's quite waterproof, it's also resistant to rusting and corrosion. Because it's a polymer, it doesn't rust. Okay, iron metal will rust. Now, polypropene as well as polyethylene, they are considered polymers, but there's one big problem. The problem with these polymers is that they are non-biodegradable. That means they do not decompose naturally when left thrown into the soil. If you throw these into a landfill, they do not degrade. If they do not degrade, they remain on land or in the sea for a long time. Okay? For a long time. And this could cause problems. It will cause land pollution. You will eventually run out of space for landfills. It will also cause sea pollution, the water pollution, because even though it does not break down, it can float on the surface of the seawater and be mistaken by the ocean creatures as food. So the turtles, the jellyfish even, may actually consume some bits of these plastic, some bits of this polymer, and it could end up inside their digestive systems and it cannot be digested. So over time, these turtles, these ocean creatures, they may suffer starvation once they eat these plastic polymers. Okay. Now, inside your notes, we cover other important details, such as how do you recycle polymers, the physical and chemical methods of doing so. May I please encourage all of us, even after doing the summary, to ensure we read the notes so that you are absolutely familiar with things that we may not have covered here, but are still important. But what I've covered here should be the bulk of what you need to know, a good starting point for you to start revising alkanes and alkenes. So this concludes our first video on alkanes and alkenes. Now the next video is on alcohols and carboxylic acids, which will be relevant for the O-level students. Okay, so I'll stop the recording here. And if you are unsure about anything, just ensure you rewatch the recording. Okay.